This episode forms part of a series we're running on CockroachDB, powering AI or ML workloads. Today, specifically, we'll look at how CockroachDB can back an agentic AI workflow. In today's example, we'll set up a fictional coffee shop based in my favourite part of London, Camden Town, and our business smarts will be driven by agentic AI, principally to control the pricing and promotions of our coffee based on our local competitors. For this demo, I'll use LangChain and LangGraph. LangGraph to form the basis of my agentic AI workflow. While I think about it, you could also use CockroachDB's vector support to drive RAG into our agentic workflow, and you could also call off to MCP servers if you didn't want to interact directly with the database. I won't be doing those in this example. This is just going to be cut back agents, LLM, and CockroachDB. The start of our workflow is here, and the first thing we do is an inventory analysis. We'll fetch our current stock of all the coffee. I'm treating each coffee like a discrete product. We might have 500 Americanos in stock, for example, just to simplify things, although the same could be done with a kilogram of beans, to see what opportunities we have to play around with pricing based on stock and also price. So we'll fetch stock and prices from the database. Then we'll send it off to a market research agent. This agent's job will be to go out to the market, see what prices other coffee shops are offering in Camden Town, and pass that along to the next agent. This will be fetching data from a large language model, and it will forward it over to the pricing strategy agent. This agent will rationalize our pricing strategy before sending it over to a promotion coordinator. This coordinator will write data to CockroachDB if it finds the opportunity to create a promotion. For example, our coffees are priced too high and we might want to introduce a discount to customers. And our last agent will perform performance monitoring, and this determines the success of our pricing strategy. And then we finish. I'll start CockroachDB down here, and with that running, I'll create some tables to store our products and I'll insert some data. Now I'll run a workload, and this will simulate customers in my coffee shop. So we've got customers coming in, they're adding to a basket, which is essentially just asking for products, and then they're checking out, they're paying for their coffee. The first thing I'll do is update my prices, setting some of them way above market price and some of them below market price. And then I'll set the stock we have on hand to a fairly high number. I also have a function that shows me the amount of stock I have, the current price, the last time the price was updated, and information relating to the average sale price of a product. We'll notice that because customers are buying products at their current price, the average sale price is the price of the product. As we tweak that, you'll see this value changes. We don't have any promotions on for any of the products at the moment, hence we have 0 redemptions. If this is what my agent workflow looks like at a bird's eye view, in code, it's more or less the same thing. I have an orchestrator that is aware of our large language model and the database. In this class, I have a bunch of functions that access the database. And then I have my agents. Some are aware of my large language model and others are additionally aware of the database manager. We build the graph. So we add all of our agents and then we create the workflow by adding edges. So for example, the first node is start and that points to inventory analysis. And that creates the flow we see here. Let's run my agent workflow. So that's finished now, and all of the agents would have been called. We performed our market analysis, and it recognized that the price of our Americanos is higher than the competitors, who are pricing it at around $3 versus our $5. And it also noticed that the price of our cappuccinos is significantly lower than our competitors. Currently, we don't have any inventory risks because we've set a high stock level for each of the products, but we have created some price recommendations. Any products that are below the market average, we'll apply a gradual price increase to get us closer to the competitor average. Same for any products that are above market average. We'll introduce a gradual price decrease. And because our stock levels aren't posing a risk to the business at the moment, none of the price strategies here relate to stock. We've created 5 promotions. And if we call our product stock function again, our prices have actually been decremented by the agents. We've introduced a 15% promotion on all of our products that are currently being redeemed by our customers. If I refresh it again, you'll see those numbers go up. We last updated the price a couple of minutes ago, and the average sale price is coming down because I've coded the workflow to look for promotions where available. So the prices are slowly coming down to a market average. Let's try another scenario. Let's set all the stock to be low now, and the customers aren't slowing down. If I run the agent workflow again, that's finished. This time we haven't created any promotions because we don't need to, although we have adapted the prices slightly. Note here now that because we have a stock out risk, because of perceived high demand, we're actually recommending a slight price increase to help cope with that supply demand problem. That was CockroachDB for agentic AI. We didn't go too deeply into the code, but I didn't have to make any changes to LangChain for it to work with CockroachDB. LangChain saw a Postgres compatible database and just spoke to it as if it were Postgres. Hopefully that gives you an idea as to how flexibly CockroachDB can be used for your existing or your new agentic AI workloads.